In this recording, we will be looking at how we can use differentiation to find the equation of a tangent to a curve. So we have the equation of the curve. Find the value of dy by dx when x is equal to 1. It's just a straightforward question here. Let's differentiate. You might want to remind yourself of why we are differentiating. So it's to find the gradient function. This question is basically asking what is the gradient of the curve when x is equal to 1. If we drew a diagram, our curve might look something like this. What is the gradient here when x is 1? Well, we know the gradient of the curve changes all along your curve for the different values of x. So specifically when x is equal to 1, if we differentiate, we get the gradient function, which allows us to find the gradient at that coordinate point. How do we differentiate? We times by the power and take 1 off the power. So 2 times 5 is 10. Take 1 off the power, power 1. We've got 3x to the power 0. No, we haven't. We've got 3x to the power 1. So times by the power, take 1 off the power, gives us x to the power 0, which is 1. So we're just left with minus 3. And our constant term disappears. So find the gradient when x is 1. So when x is 1, all we need to do is sub that into our gradient function. 10 times 1, take away 3, 7. So the gradient of our curve when x is equal to 1 is 7. Okay, have a go at these questions now, please. Find the gradient of the tangent to the curve at the following points. Maybe put me on pause, have a go, and unpause when you're done to see if you're correct. Okay, so for this first question here, let's differentiate to find the gradient function. Now, at the coordinate point 212, x is 2. So if we substitute x is equal to 2 into this gradient function, so our gradient is 12. Find the gradient of the tangent to the curve, y equals x squared plus 4x. So if we differentiate, times by the power, take 1 off the power, we get 2x plus 4. So when x is equal to 1, put that into our gradient function. 2 times 1 plus 4, 6. So the gradient is 6. Find the gradient of the tangent to the curve y equals 2x squared minus x minus 1. Here we've got x is 2, right? So let's find our gradient function first. Got 1x there, so differentiates to give us minus 1. Four times 2, take away 1 is 7. So our gradient is 7. Okay, some slightly more complicated questions here. Again, maybe put me on pause and have a go. So just remembering with this, we've got y equals 1 over x. To differentiate, we need to have it as x to the power n. Not in the form, none of these are in the form x to the power n. So if you remember, 1 over x is the same as x to the minus 1. Times by the power, take 1 off the power, minus x to the minus 2. So when x is 1, we just sub that in here. We'd have minus 1 to the minus 2. You can put that into your calculator if you want. It is just minus 1. So our gradient is minus 1. How do we write y equals 1 over x squared? X to the minus 2. Differentiate. Minus 2, x to the minus 3. Sub in x is equal to 2. Minus a quarter. So our gradient here is minus a quarter. Next one, root x is the same as x to the power half. Differentiate. Sub in x is equal to 4. Our gradient is a quarter. Cube root of x is the same as x to the power third. Differentiate. Sub in x is equal to 8. That should be 2/3 there. Didn't really look like that. Gives us an answer of 1/12. We're going to look at a slightly more in-depth question. We've got the curve has equation y equals 2x squared minus 3x plus 5. We've got a quadratic curve. Point P lies on the curve and has coordinates 3, 14. Find the equation of the tangent to the curve at P. Give your answer in the form y equals mx plus c. Sometimes it's useful to have a little diagram here to look at exactly what's going on. We've got our curve. It says the point P lies on the curve and has coordinates 3, 14. So let's say that's approximately here. There's our point P. Find the equation of the tangent to the curve. So let's draw a tangent, asking for the equation of that tangent there at the point P. So what do we need to find the equation of a straight line? We need a gradient and we need a y-intercept. Now, the gradient of the tangent here is exactly the same as the gradient of the curve at that exact point when x is 3. So first of all, we can use that fact to find the gradient. So let's differentiate my curve. 4x minus 3. We need to find the gradient when x is equal to 3. So the gradient is 9. I'll just write that down. Gradient is equal to 9. Now, the equation of our tangent is y equals mx plus c. We've just worked out that m is 9. We need to work out our y-intercept. Well, how do we do that? Do we have a point on the curve? Yes, we do, with 3, 14. So we sub in that information into our equation. Sometimes you're not given the y coordinate. If you're not given the y coordinate, you would sub 3 into this equation here, would give you the y coordinate. We need to make C the subject here, so let's take 27 off both sides. C is minus 13, so the equation of our tangent is y equals 9x minus 13. We have two questions here. Maybe have a go at yourself of these questions first. Put me on pause and pause when you're done. Okay, let's start with this first question here. Find the equation of the tangent to the curve y equals x squared plus 3x plus 1 at the point where x is 2. So first of all, we need to differentiate to find the gradient function. So when x is equal to 2, our gradient is 2 times 2 plus 3, which is 7. M is 7, the gradient is 7, what we could call it dy by dx is equal to 7, or we could just call it the gradient is equal to 7. But it's the gradient of the tangent, because the gradient of the tangent and the gradient of the curve are exactly the same. So here we know M is 7. Do we have a coordinate point on that line? Well, we don't, but we know x is 2. If I put x is 2 into this formula here, we will get to the y coordinate, which is 11. So when x is 2, y is 11. Let's take 14 off both sides, gives us our intercept is minus 3. So our equation is y is equal to 7x minus 3. Question 2, find the equation of the tangent to the curve y equals 3 plus 4x minus x squared at the point where x is 1. Okay, so again, let's differentiate first to find our gradient function. Times by the power takes 1 off the power, 3 disappears, 4x, we've got 4, and then minus 2x. So when x is 1, dy by dx, our gradient is 4 minus 2 times 1, which is 2. Okay, now we need a coordinate point to find our equation of the tangents. All we know at the moment is the gradient is 2. So y is equal to 3 plus, well, we need to work out y when x is 1. 4 times 1 minus 1 squared, which is 6. So when x is 1, y is 6. So our y-intercept is 4. And our equation is y is equal to 2x plus 4.